one more inverse trig function to go. You might say, no, wait, there are 4 more. Well, sure, there are 4 more, but we're only going to do one more. We're going to do tangent. The secant, cosecant, and cotangent all have inverse functions as well, if you restrict the domain the same as their reciprocal functions. But we won't worry about those functions in this class, so you can just get sine, cosine, and tangent down, and you'll be in good shape. So once again, you should do this before watching the video. A lot of this is going to be exactly the same as the last 2 pages. It is not one-to-one because it fails the horizontal line test. This time we are going to center it at 0 again, just like we do with sine, and we're going to go up forever, or to pi over 2, depending on your perspective. And we're going to go down forever, or left to negative pi over 2. So that one branch fits the important requirements of hitting all of the domain, all of the range of negative infinity to positive infinity, and it is still one-to-one. So notice that this is different from our restriction for the sine function in that we don't include the endpoints. We don't include the endpoints. By endpoints, I'm talking about these endpoints, the negative pi over 2 and the positive pi over 2. Those aren't part of the domain. Why? Because of the vertical asymptotes. The function is not defined there, so it wouldn't make sense to include that as part of our domain restrictions. And of course, our domain restrictions become the range of our inverse function. Once again, the inverse tangent function or the arctangent function, they are interchangeable. So from negative pi over 2 to positive pi over 2, where there were asymptotes. Well, there are still asymptotes at negative pi over 2 and positive pi over 2. The key difference here is that these guys are not vertical asymptotes. Why? Because we're taking the inverse, and when you take the inverse of something, you swap everything vertical with horizontal, everything horizontal with vertical, x's and y's, domains and ranges, vertical and horizontal. So 0, 0 started off on the graph, it's still on the graph. Pi over 4, 1 was on the graph, now it's 1, pi over 4. And we're going to continue to shoot off towards infinity. Oh, I crossed over the asymptote. Don't want to do that. Alright, something like that. Same thing in the other direction. Here is the inverse tangent function. So we'll fill out the chart here. Once again, because we know that that's the old domain, it's going to be the new range, and the old range, which was all real numbers, is once again our new domain of all real numbers. Our graph of the inverse tangent of x can take on any value we want to. We can take the arctangent of 1, or 2, or 3, or 4, or 5, or 6, or 7, or 8, or I think you get the idea. And we can go in the other direction as well. So there is no limit to the number we can put into the arctangent function, unlike the arcsine and the arcsine functions, right? Those domains were, well, I'll let you go back and look at what those domains were. You should already know that by now. Alright, so same question again. We want to find an angle whose tangent is √3. So we remember from our unit circle that tangent starts at 0 when the input equals 0, and it goes up from there. √3 over 3, 1, √3 is up here, and that corresponds with pi over 3. The tangent of pi over 3 is the square root of 3. The tangent of what equals 0? The tangent of 0 equals 0. The tangent of what equals -1? Well, remember, whoa, what happened there? Let's back up. Here we go. We got tangent of some mystery value equals +1 up here. So if we go the other direction, we'll go to -1, and that's the, your 45 degree, you're halfway between, and we know that in radians, that's the same as pi over 4, but we went in the negative direction, so this is negative pi over 4. Do not put 7 pi over 4 for your answer here. That would be incorrect. So we've got last one here, back to positive, so we're back to quadrant 1, so this would be the shorter one, back over here. That would be the first one we get to. That's the closest special value to 0. So that would be pi over 6. And that's all there is to arctan.